Hey there. Yeah, good to see you all. I must say, I was actually mind blown by this Slava's presentation, and I have one question. Maybe Slava will be able to answer that later. Can we hot reload WinForms? I would really like to use Dart with WinForms. Uh, welcome everyone. I'm Dominik, and I think I will have some common things with Slava's presentation. So Slava mentioned that he's a dreamer, and he wishes, like, for some of these things to eventually land in Dart ecosystem. And I'm also a little bit of a dreamer, and I also want you to leave with a little bit of inspiration after this talk. And I must say that the story that I'm going to tell you today is mostly like about a small dream that came true this year for me as a developer. And it's like almost like changing tires while driving kind of thing. So I hope you will enjoy that. But also following the advice from somebody earlier, let me just introduce myself. So I'm Dominik. I'm a Flutter GDE. I've been doing Flutter for a while now. Before that, I was working, for instance, with Xamarin. So if there are any Xamarin developers, maybe former Xamarin developers, could you just clap now? Yay! I'm happy for you that you joined Flutter, or at least are interested in that. And at the moment, I'm building a product called Visible. Visible is an app that is aimed to help people with long COVID, chronic fatigue syndrome, and some other illnesses that just became quite popular after the recent pandemic. And this is a journaling app that helps people maintain their physical and emotional level. And we have a couple of cool features in there. So it's a symptom tracker as a free app. So people tend to use this to track their symptoms, to guide themselves through the day. They may use this with some medical advisors and stuff like that. But at the same time, we also have a wearable integration. This is a premium subscription, and I'm wearing this right now, which is kind of cool because after the talk, I'm going to be able to see the profile of my heart rate during the talk, and I can feel that this is rising super quickly. So we have this, and this has been a major challenge for us, but we managed to solve that. And as we are quite small team, there's only 2 developers. We have a very thin layer of backend. This is just, so we are mobile first. We optimize for speed, time to market. So we have a quite flexible low code / no code backend using something called Hasura, and a bit of a cloud function, a bit of a Python just to analyze some of the data that we collect. And I'm also super happy that the app is quite pretty and very well designed. So this project has been on my mind. I've been involved in that for more than a year now. And during this time, we took a lot of shortcuts. We wanted to deliver as quickly as possible. And of course, whenever you take some technical debt, you have to pay it off later. But at the same time, thanks to that, you are able to deliver quickly, get a feedback from your users without waiting too much, and so on and so forth. So today I'm going to tell you a story about how we had to actually just repay this debt at some point. So in December last year, we launched our public beta. It was like a very first initial version of the app that was capable of journaling and having some free features. We had early adopters, like 100 people group that was super invested into testing our application. And they were helping us. These were people from long COVID community that were helping us to just see if it actually works for them, if they can manage their illness, their symptoms with that. And the feedback was quite good. Like the initial 100 people stuck to the app. They wanted to use that. So in December, we had a public launch. $0 spent on marketing, just word of mouth, Facebook groups, WhatsApp groups, stuff like that. And it actually went pretty well. Like it became popular quite quickly. In just first week, we got thousands of users, and it became like, for us, 2 developers team. One of them joined like 2 months earlier. We were just starting up. We suddenly got thousands of users using daily the app. So this is a journaling app. So they come to the app at least twice a day, kind of pushing the boundaries of what we have expected much higher. So for us, I'm not a backend developer, but we had to just work with that, what we have. So for us, it was quite scary. Like, will it like survive? Will we be able to sustain the load? But in fact, what happened is like it easily worked. Like, so for us mobile developers working in like this small screen factor, we tend to sometimes overestimate the impact of the load of like thousands of users, especially in the current era of like scalable cloud infrastructure and stuff like that. And again, I think it's getting super cheap right now. But still, like we managed to get these users. They were not offended. They were not leaving the app. So they were using the app, and in like 2-3 months, we got to over 20,000 onboarded users, and they were using the app daily. The retention was super high, like 5-6 weeks, easily at 90%. So we struck this balance. Like we found like our product that actually worked for the people, and we were super happy. Like everything was going so well. The feedback was amazing. We were getting App Store reviews. We were getting intercom messages, Facebook recommendations, Twitter threads. I mean, what else you could wish for? Like it was super cool, and I must say that was one of the best times as my developer life. Like after many products that would never launch or something like that, this was a super exciting thing, and I hope that you can see even now recalling that I feel very excited and very emotional because this was actually a great achievement for us and our small team. However, as I said at the beginning, we took some shortcuts on the way. We knew that we're gonna have to pay it off. We're gonna have to revisit some of the things that we had to simplify. And I must say we were quite naive in many of the let's say modules of the app because we wanted to deploy as quickly as possible. And in some cases, especially if you have a startup, maybe a product that you haven't verified just yet, that might be a good strategy. Of course, there's another spectrum, like a point on the spectrum where you like prepare for many months, you build like an amazing architecture, you scale it from the day zero, where like probably you also will be very happy with what you've built. But here we are, we have to deal with what we have. We have to play with our cards, and unfortunately, there was one like a problem that actually started to cripple after we got to this like scale of thousands or tens of thousands of users, and we only had part-time one person as a customer service, and they were overwhelmed with the amount of messages and stuff like that. So the thing that we were seeing was just a massive amount of crashes slash exceptions. So in the screenshots, these are not necessarily crashes, because if you have 9,000 crashes a day as a like a app crashing, you would just be banned from the Google Play and App Store. It's like Crashlytics just falsely reporting different exceptions as crashes. But we got like thousands of them daily, and it was quite overwhelming, and this was mostly due to the network issues that we were seeing. As a first resort, what do we do? Like, we are good developers. We can do whatever we want. So we try to do what every developer tries best. We just put error states. Many error states across the app. Like everywhere where something would fail, we just put an error state. We put like a snug bar, stuff like that. And I mean, this, we thought it's going to help. Like, people will have like a try again, so they will just try again. But in fact, it actually didn't work so well. So it only surfaced the issue so that we would see like a lot of screenshots from our users that, hey, this doesn't work. I can see this error screen all the time. So what were the issues that we were seeing? And it was a little bit of a bummer and like a down, like emotionally very difficult time, because we wanted to build features, but at the same time we were facing a lot of the issues and exceptions and stuff like that. So we were facing random issues, but they were all like related to network connectivity mostly. So for instance, we would have an issue with a Firebase token that would not refresh when you open the app. So suddenly, because we were driving our app state on the authentication status of the Firebase token, it would suddenly just end up in a login page, not on the home page. And it would just happen like, we couldn't reproduce that, and the token would just fail to refresh automatically using Firebase SDK. We were using GraphQL with Hasura, which is an amazing tool. It like sped up our development by months, but at the same time, we were actually over-relying, I would say. We were relying heavily on the GraphQL subscriptions. So we wanted to have like close to real-time experience. So you add your, you do your morning check-in where you put your symptoms, and we wanted this to be seen in other places where you see your journal. So we were just relying on like a round trip of a GraphQL mutation, saving data to the database, and then subscription emitting this elsewhere. And as you can see, like at first it worked really nicely. This is a shortcut that we took, and we were able to show it in like 1 day. But in a scale of thousands of users, it was just too slow. It would take seconds, if not even longer. The subscription would just fail sometimes. Especially, let's say you're an elevator parking lot in a rural area, like it would just fail. And of course, like as a good developer, you would try to add some retries, some timeouts, make sure to like embrace that. But again, it was not always working just like that. And we had plenty of features. They were not always built exactly the same way, and it just meant that it was quite tricky to, it was like a whack-a-mole game where we tried to solve all the issues one by one. And like the biggest, I think, factor that contributed to that, aside from the, I would say, poor architecture, was that we as developers and product founders, we tend to either like live in a good network conditions, or we have like a fancy computers and phones with 5G connection, and typically we never actually have real connectivity issues. And once you get to these for instance, our demographics has this, like they tend to live in smaller towns, rural areas, stuff like that. And if you think about it, how do you test for internet issues in your app? You would typically just, I don't know, turn on the airplane mode or turn off the Wi-Fi, stuff like that, which does not actually reflect what is happening when you have your phone in the wild, when you have your app in the wild. So this was actually one of the issues that we were facing. And so, of course, we started to test the app in much more difficult conditions, but it was still difficult to pinpoint all the issues. So we started patching things up. We spent a couple of days fixing the network failures, adding some retries, making sure that we do all the things more or less consistent across different modules of the app. So for instance, we added these retries, we added connectivity checks, so just to make sure that if there is no connection, we maybe delay a little bit, stuff like that. So many things were happening. I'm not going to get into details. And as I mentioned, we were using GraphQL, and GraphQL as a really splendid technology has many different things that are built in, like optimistic updates, caching, restarting, things like that, that you take, like they are just built in, and especially if you use some of the libraries like Fairy or GraphQL, they typically have these kind of things included, and you just need to configure them somehow, maybe provide ability to store this in some kind of local store. And it actually really helped us like to keep these things. We were seeing much less issues. But at the same time, we were still relying heavily on the WebSockets, so they were quite chatty, and we, for instance, were encountering like a lot of the bandwidth usage. We were encountering battery drain. So if you think about it, if you have a WebSocket and you tend to kind of update this every few seconds, and let's say you don't do pagination just yet, again, very early stage, first month or first 2 months of the app after release, so you don't think about pagination just yet. And so things start to pile up, and you're not a good citizen as an app on your phone, right? So you want your app to not be in the top 10 battery draining apps, right? You don't want your Android phone to notify you, hey, this app tends to take so much of your battery, maybe you want to snooze it. So we really wanted to kind of behave well, so we tried to think about other ways how to improve that. And also with time, especially after like 3 months mark, and we had like these thousands of users, it started to become quite slow. This amount of data getting sent all over again, back and forth. And back then we still had our server in US. It meant like it would take some time, especially when we're still relying on this round trip of the message from to the server and back through the WebSocket. It would mean that you would see your updates like 5 seconds later. So let me give you a quick insight into how it was structured at first, and then we're going to show you how what kind of changes we applied to this. So I'm following this very basic architecture where we just have a couple of layers, nothing fancy, but I think it paints the picture of what it looks like. So at the top, we just have this like UI logic kind of layer. We tend to stay in the Flutter block ecosystem where we have qubits and blocks, sometimes stateful widgets, like whatever works for a given use case. And they typically operate on the data that comes from the repositories. Repositories are glue layer between the UI and the things that tend to typically just fetch the data or send the data somewhere. So we may have a GraphQL client, but we also may have Bluetooth or like a device client that connects to my band. So I'm wearing the band actually right now, and the band sends data to my phone, and there's like a Bluetooth client that takes this data and saves it somewhere. And then if I want to see my data, I will access this through some kind of repository. Very basic, but I want you to kind of be up to speed of where we are. So one thing that you can do to improve this, especially with these chatty WebSockets and things going round trips, and maybe utilizing also optimistic responses, is just to add like a additional caching layer. And this is what many apps try to do as a first resort when you want to improve your offline support. You may add like a HTTP caching. We added a caching in form of a behavior subject in many repositories. So for instance, there would be like a major stream of data, let's say stream of users, stream of observations, stream of symptoms, stuff like that. And so anytime you change something, let's say you send a mutation to the backend, you would update the stream. And the stream then would emit this to any of the listeners, any of the qubits or blocks or widgets that would require that. And on top of that, we also used something called hydrated block, which is a caching layer that you can build, augment your blocks with. So whenever you open the app again, it will just read the state from the cache. And this is quite interesting. Let's say you may want to be able to read your preferences, or maybe you want to read your user before you get authentication, confirmation, stuff like that. So this, we thought, okay, we are done. It's going to work just fine. We're going to use these behavior subjects and stuff like that. So I'm going to my founder and saying, all right, this is going to work. Let's just release that now. And I think it's going to be fine. Please test it out. So we tested this internally. We tested this with our devoted users. And then we get another batch of different error reports and intercom messages. And there's still like a wave of people saying, hey, it still doesn't work. It still fails to load the data and so on and so forth. And at this stage, it was quite tricky and hectic because we have our goal to build more features, deploy new things into the production. We promised, or maybe not promised, but we announced some things. And you have only some time, like limited time to build things. So like one of the things that when we started digging deeper into what is actually going on was this one. And I wonder, in this room, how many of you have ever seen this kind of error message somewhere? I can see some hands. So I don't know if you ever read your error messages, but like this is something, and maybe Slava would be good to explain a little bit more what's going on with that. But it's a quite common thing, and I've seen many of the Dart, maybe not many, but a couple of Dart issues mentioning that, and there was never really a good way to reproduce that. It just happens sometimes where like just the header is not received or something like that. But underlying issue is definitely something related to networking. And I think it happens more often on iOS than on Android, but still it can happen at, I think, on any architecture. And there's ways around this, like using Cupertino HTTP client, stuff like that, but it was happening to us, and we kind of wanted to solve this in a bit more general fashion than just squashing this little bug. Then there was this one, and I think there's also it is also quite common when you look at your HTTP client error messages. It just fails to find the DNS, fails to resolve the domain name and stuff like that. And the tricky issue with that is that, like, if you use like connectivity checkers, maybe you ping a server or something, it may indicate that everything works well. Like, you don't know that you don't have internet connection. It just, whenever you have this call, it just fails. And if there was a nice way to reproduce that, we could put a lot of try catches around this or something, and just retry. But retrying is not always the best way to solve that. And even worse, we have this critical path where the user is prompted in the morning to open the app, do their morning check-in, which means you put your symptoms. Maybe you measure your heart rate with the armband or with the camera. And this is a very important part of the general experience. But the problem is, like, we want users to, maybe that's not a problem, but we want users to do this as the first thing in the morning, because we believe this will help them to have like consistency across measurements. But sometimes, let's say on iOS, I think it also happens on some of the manufacturers for Android, when you open the app, when you turn on your phone in the morning, maybe you didn't connect this to the charger, you will not have internet connection, just for a few seconds, like 10, 20, 15 seconds, something like that. But it's enough for us so that like when the app launches from the notification, the user is not able to fetch the fresh data, or when they try to send something to the backend, the loading state just spins and spins and spins, even though you try to retry, and the system doesn't actually openly tell you that you don't have the internet just yet. So it's like a very funny state, and it's also not easily reproducible, because it's not like you can turn off Wi-Fi and turn on Wi-Fi. It's not this kind of situation. So this is the moment where we, like, after a few weeks of tweaking this and spending time and not being able to like focus on actual features that we want to deliver to our users, we decided just to take a step back, right? Just to like maybe release some like energy and kind of make sure that we approach this issue from a different point of view. And so this is when I'm saying we wanted to change our tires while still driving the car, because this was this kind of endeavor where we actually didn't want to stop releasing new things into the app. So we had different versions of the app during this time. And we also wanted to have backwards compatibility. So all the users that we gained, we didn't want to force upgrade them just because we changed some underlying infrastructure in the app. We considered that, but we realized we don't want to, especially because our users are not super tech savvy. The demographics is such that they may not even understand what does it mean to update the app, stuff like that. So we have to be very careful whenever kind of asking the user to do something like clear cache, right? It's not something that people tend to know. So offline first concept, it's like reinventing the wheel. I would say, like, I've seen many talks on how to approach offline mode on various conferences. At any bigger event, there is at least one, if not two, different talks about this. If you search for that, you're gonna find thousands of different articles and videos showing how people would approach this. And I've been talking to many people, and I'm super happy to talk to you as well after the talk, like how you approach offline mode. Because what I'm gonna show here is just one example that worked for us really well. And we were super happy about how it came out. I'm spoiling this. Shit. But for many other apps, there's like a completely different set of things that they would do. Or maybe they have a completely different architecture. Maybe they use Riverpod. Maybe they use even just native app. But the important thing is that these things have already been done. And I think if you go a little bit meta, I think in the Flutter ecosystem, I think this topic has never been properly introduced, properly taught. So whenever you are being taught how to do your first Hello World app, you may have a button and you do the network request and then you wait for the response. And I think that's nice to start, but at the same time, I think we should do a better job as a community to show how we do this in practice. How do we actually do production apps that need to sustain much more different set of constraints than just a simple Hello World tutorial. So what I'm gonna show you here is just our way how we approach this. And I hope you're going to share something with me as well after the talk, or maybe through the Slido. All right, so the first thing that you always need to have with the offline first, some kind of local storage. Local storage for you is just to make sure that you keep your data whenever you don't have internet connection. And there may be many ways to do it. I'm not going to go too much into the details here, but there's like, if you look for different databases for Dart and Flutter, there's like Couchbase, ObjectBox, Realm, SQLite, Hive, ISAR, you name it. Like, there's many more. And we had to set some set of constraints. So unfortunately, we crossed out the three first elements, the three examples here, because they are mostly NoSQL databases. And we wanted to limit the cognitive load that we have. So because we have a Postgres database on the backend, it would be nice to just like mimic what we have on the backend on our in our mobile app, so that we don't have to translate from one paradigm to the other. So we obviously went with the SQLite. And SQLite has a couple of other benefits compared to other solutions. So this is a solid choice. You will find a massive amount of materials about this. And it is cross-platform. It works from the native code. So as we have a lot of native integration, like with the Bluetooth band, with the camera, now with the database, we wanted this to be accessible. And also, like in the future, we want to integrate with the Apple Watch. We want to have Apple Watch extensions, maybe things on the Android watches as well. So having ability to access the same database from the native side, not only from the Flutter, this is a really big and important factor for us. And when it comes to the Flutter experience, at this time, like almost a year ago, only, maybe not only, but like SQLite had the best support for isolate, accessing the database through the separate isolate, which means that if you have a long query, or maybe you write a lot of data, a big batch of data into your database, you can just offload this to a separate isolate and don't see junk in your app. The UI does not freeze during this process. Whereas other solutions like ObjectBox, which is amazing, like they have, for instance, offline sync in the background, which like if you would use SQLite, you have to do it on your own. But ObjectBox was not able to support isolate queries on things that have on objects that have relations. And one important thing that we had to do, and this is related to the fact that we were changing these tires during the car ride, was that we already had some models established on the backend, and now we are trying to port them to the mobile app. And it's not always one-to-one relation. So first of all, we wanted to limit this cognitive load. Just like, in fact, what I just did, I just opened my database on the left side, my VS Code on the right side, and I tried to go line by line and build the models manually by hand and see what works, what doesn't work, what do we need to have. But there is like one challenge that we had to solve, and again, this has been solved multiple times in the past, but we approached this, I think, in the simplest possible form, because we didn't want to change the schema of the database. I mean, we didn't want to remove things from the remote schema, but at the same time, we kind of wanted to maintain the backwards compatibility and stuff like that. So whenever we were sending things to the database would assign ID, and we would get the ID from the database back, and this would be a the primary key that we would use for this entity. But the moment when you, and this is an important word, decouple the creation of an object from saving this to the remote database, you suddenly cannot get the remote ID when creating the object. You are creating a new observation, a new entity in your local database, and it cannot have the remote ID just yet because you haven't sent it to the backend. So what we had to come up with is just a local UUID, which now became our primary key locally, which I think is quite important to now like switch from one model to a model where you have double IDs. You have the backend ID, you have a local ID, and then eventually they need to all match up. And this is important because now locally you cannot always rely on the remote ID being there, being present. And this is something that if you were to start with offline first on a greenfield project, you probably wouldn't have to deal with. But when you have a project that has been running for a while, this is something to remember. And also the relationships. We wanted to leverage the relationships. So thanks to the reactive nature of SQLite, you can, if you change one thing in one place and it's related to something else, we have a foreign key, is going to be updated in the other place as well really easily. You don't have these, like, for instance, key value store where you change one key, but it doesn't affect any other keys. And this is the only snippet in this entire talk is just a Dart class that was describing one of the models. And we were using a library called Drift to access the SQLite, which is an amazing library. It has a really nice syntax to create the models. Of course, you still need to run build runner, which I'm not the biggest fan of, but thanks to that, you can actually just write human readable definition of your database models. And I've been like teasing this for a while now, but we also needed to have a way to queue, like to postpone all the user actions that they were doing for a later time. Let's say when they have an internet connection, or just to not couple the UI action with the network request. So this is quite important because, as I mentioned, like we are taught often when you have a button, and even if you go through the blog, even if you go through the provider, you press a button, you have a big loading state, waiting for the request to process, and then after it's done, you have a response. And you can have multiple layers where all this complexity is hidden, but in the end, the button loading state is tied to the network that's going on in the background. So what we wanted to do is to decouple these, and like when you press a button, something is saved somewhere, and then another process just takes it up in a few seconds and executes and then notifies whether it succeeded or not. So that right now, this unlocks a lot of the possibilities for things like optimistic updates, removing loading states, and such things. So let me quickly explain how we approach this in our quite, I would say, straightforward way, but also I think this can be scaled to much more complex cases as well. So I've been mentioning this morning check-in for a while now. So whenever you do this check-in, you put your symptoms into your app, and this gets saved through the observation repository. So this is like a conventional name that we use. And before that, it would just run the GraphQL mutation and wait for the response. Here, what we are doing, we are just saving this to a table in the database, table of observations, and it just stores there, like a new entity with new ID with no remote ID. Then, as a secondary requirement, we add the node to, or like an entity, which we call synchronization task. Again, the naming is completely arbitrary, but this entity has some metadata telling which object has been added, what has been done, like the object has been added, in this particular case, observation, when, if there would be many users by whom, and so on and so forth. So we have this thing. And then through the magic of debouncing of the stream, in few seconds, the other module that is responsible for like listening to all the new tasks. All right, so here's the new task. I need to execute that. And there might be some handler for this task, some definition how to execute this task. So in this particular case, for the task called add observation, you just need to call a mutation on your GraphQL endpoint and save it to the backend. And the cool part about this is that before that, the observation repository would call the GraphQL client, and now we completely decoupled these one from the other. And there's, of course, some linking there, but it's not like it happens in a sequence. There may be arbitrary long time between these events. So after the GraphQL client gets the response back from the backend, the observation is being saved, again, updated in the database. So anybody who would listen to this observation stream immediately gets information that, hey, this observation has been updated, and finally it just marks the task as done. The task is no longer getting picked up by the action queue, and then in a few days it's going to be just pruned and removed. So the process is quite simple. It's just like a one loop of things that happen one after another, but there's like this nice decoupling that I really like, and it just made the general concept much easier. And what you have to do is essentially need to find all the user actions that you have, which is basically all your mutations, and you rebuild them in a way where you decouple one from like the user action from the network request. And in cases like deletion or editing, it's going to be a little bit more complicated. But in case of just adding new stuff to your database, and we are talking basically about any other CRUD, this is how it works. The amazing part about this is that optimistic updates, you get them for free. So for instance, you may do your morning check-in, you added your sleep rating, and it's just there. You don't have to wait. There's no loading state at all. It's just there. And in a few seconds, it's going to be sent to the backend. And when you update that, it also gets visible immediately. And it may not be exciting, but if you compare it to the previous experience where you had to wait for the request to finish, loading, 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 you were in the, like a rural area, it would just fail, it would be super annoying. And as a developer, we had this tool just for us to show us the progress, right? So let me show it again. We would have like a queue of actions present, and you could just observe this, and we can remotely even debug a user by just sending the local database to us and see like if any action failed, what are the issues, if there's an error, we can troubleshoot that and stuff like that. So within few days, we were able, or like few, maybe weeks, we were able to spot some of the issues that people were having, and eventually we were able to solve most of that. Another thing that always pops up when talking about offline mode is the background synchronization. So theoretically, you can run the app now with no internet connection at all, like indefinitely, aside from some of the features that require network connectivity. But like things that are just CRUD-based, like CRUD-based, you just add, remove, edit, delete stuff, they can all work locally. But of course, sometimes you just need to have background synchronization. So what we did is we have like just a process that kicks off in the background using Work Manager when the user connects to the charger, also in the morning when they open the app, things like that. So we had to remember to fetch the data from the backend and execute all the actions that are pending. Let's say if a user made a lot of actions and then swiped away the app, the actions would not be executed because Flutter is no longer running. So we have to have a way to run them in the background as well. Conflict resolution. Somebody would ask, what about that? We don't have to worry too much about conflict resolution because it's a mostly single user app. So whenever you add something or edit, you're the primary source of truth, and we don't necessarily need to worry about it. We use just last write wins. So whatever, if you have multiple apps, the last app, the last request always gets the place, like they override this. If you want to learn kind of how to do this in a more serious manner, you will spot terms like CRDT, conflict-free replicated data types. And there is an amazing talk that I was inspired so much after from a few years ago from DroidCon, how Monday.com did this. And I mean, they have so much more complicated use case. They have a task app where many people can modify the same entity from many places at the same time, and they also implemented offline mode. But I remember, and I highly recommend this talk, because after this one, when I got back on plane, I just spent like 2-3 hours trying to implement what they did. And the funny part, of course, I was completely offline because I was on a plane, and I had to come up like with a thing that works with no dependencies and stuff like that. And since then, like I think 3 years ago, I've been kind of dreaming. Let's say this is a keyword for today. I was dreaming of implementing this in my own project, and I think that we actually were able to succeed. So this is the crash numbers, or like exception numbers after the release, a sudden drop, and this gave us a lot more visibility into all the other issues that we were facing. Big relief, and suddenly we were seeing issues that were not necessarily related to network issues. And what's even better, we were relying a lot on this low-code, no-code backend solution, which is not super pricey, but it's some cost. And due to the bandwidth and kind of sending the data back and forth, we were having like bills that were higher and higher, to the point that even the team behind the tool, they discovered that they were underestimating our usage. So at one point, they just warned us that, hey, from the next month, your bill is going to be 3 times higher, because we were not counting some kind of usage from your side. So this was a huge relief when we kind of just could drop like 90% of our WebSocket connections and just rely on some occasional updates. And like everybody was super happy. The users did not have so many issues, and the bill was much lower. And as a final takeaway, I just want to share like 2 thoughts with you, and I hope that these will be like inspiration. Like maybe as Slava mentioned about dreaming about what can be done with Dart, I have this dream about maybe Flutter apps. And these are big words, obviously. But like, if you can, you're starting a greenfield project, maybe you do some estimation, whatever. Just maybe think like if there is an opportunity to make it offline first in your preferred way. Like I think it's very exciting to reinvent the wheel in this way. Of course, you can use some of the industry standards like libraries. There are so many of them. And the other thing is like, we have this tendency to like build POCs and MVPs where you press a button, the network request goes, and you wait for the response. But maybe you can decouple these. Like you press a button, and it's not necessarily need to be like you don't necessarily have to show a loading state like right in front of the user. Maybe you can do something else, and your designer is going to be much more happy because they don't have to design this loading state over and over again. And it also puts you in a different thought process, because now you don't think about action loading result, you think about action, and then somehow the result needs to come later. I hope that this gave you a little bit of a inspiration. Thank you so much for listening, and if you have any questions, any topics to discuss, I'm looking forward to. Thank you so much. You can share some feedback with me this way, and I hope you enjoyed.
All right. Thanks a lot, Dominik.
Thank you so much.
Let's do some of the questions we've gotten here. First one that I think you can answer pretty quick. What is a Flutter GDE?
Flutter GDE, it's a title, like honorary title, granted by Google, which means that you are basically an active member of the community, trying to share and share knowledge and the passion to the technology that we have. And I hope you can see that I'm passionate about this. So this is what I'm trying to do, just share the good vibes about Flutter.
Yeah, and it stands for, what does it stand for?
Google Developer Expert.
Thanks. How do you achieve a low bandwidth connection, like, for example, 3G for doing quality assurance?
So there's a couple of tools to do that. Like on, I'm not going to get too much into the details, but like on iOS, on Simulator, you can have this tool that will reduce your perceived bandwidth. I don't remember the exact name. Not sure about Android. I would have to check. Typically, I just go far away from my router.
Question from Red. How do you handle concerns like user privacy and handling potentially sensitive medical data? Did you consider adding an optional offline-only mode?
This is a tricky one. So we, of course, try to... We are not positioning ourselves as a medical app, but, of course, collecting symptoms and stuff like that, they may be considered as a medical data. So first of all, there is like a local encryption. We encrypt everything in transit. We encrypt everything remotely. No developer has access to these data. But it's quite a vast topic legally. Like if you want to get into the medical field, fortunately, we don't have to deal with that. We are wellness app.
Thank you. From Moritz, have you thought about creating a library to basically do what you build for your app? Maybe on top of Hive plus Dia or something?
Yeah, I thought that. So actually the attempt at my during my airplane trip was meant to be like a library where you could have arbitrary storage for your actions and stuff like that. But what I've learned during the project is that typically, like in our case, the library would make things much slower. And the big benefit that we had by doing this, again, a bit manually, maybe it's not the most popular opinion, especially if you have a big team and so on, but like doing this manually, kind of bespoke for your own app, which is not a library, was actually much faster. We could iterate very much. And I mean, there's a couple of cool libraries on Pub that aim to solve this, but the fact that they are general libraries means that it may not always work for your use case.
Well, there are a lot of questions coming in here. We're not going to have time to take all of them, but some more. Some from Tobias. How did you handle errors, especially displaying them to the users?
If anything goes wrong with the action queue, we have one, I would say, major thing, which is just retrying eventually. And we, like, I'm just getting alerts on Crashlytics if any action fails, so that I know basically that, hey, there's this user, and for them, the action doesn't work. And we typically would just get the logs and try to fix that. So that's like the long route. It may take weeks, of course. But if something fails, we typically roll back to, like, we just discard the action, and the user will just not see the entity that they added. If it was like add observation would fail, they would just not see the observation. Not the best experience, I would say, But at the same time, we made this choice that we don't want to spend too much time on error handling. It was like if they miss one symptom in one day, I mean, please don't repeat this to our users. Like, it's not a big deal among like thousands of symptoms that they track.
That makes sense. Thanks a lot, Dominik.
Thank you so much. Enjoy the rest of the show. Bye-bye.